Good morning, students. We have been discussing about the various methods of concentration. So in the previous classes we have seen two different concentration processes. So one of those processes is froth flotation, whereas the other one is leaching. So today we are going to see the third method of concentrating a ore, that is called as hydraulic wash. So look at this slide. We have in our syllabus we have four different methods of concentration. So those methods are froth flotation, hydraulic wash, leaching and magnetic separation. So in this video we are going to discuss about hydraulic wash. Okay, then let us move into the topic hydraulic wash. Okay, so before entering into class we must look at this diagram. Students, look at this diagram. We have rice as well as rice husk. By seeing this, what we can say, what is the difference between these two? Can you tell me? Yes, very good. One is lighter in weight, whereas the other one is heavier in weight. The rice husk is lighter, whereas the rice is heavier than that of the rice husk. Okay, so if you are given a mixture of these two, rice husk along with rice, how we can separate? What is the property associated with them? Yes, very good. The property associated with them is different in specific gravity. Okay, so the method of separation of these two things is winnowing. Okay, so this is a picture of winnowing. This you might have seen in your lower classes itself. Okay, when we do like this, the lighter husk will be moved far away from the rice. Okay, so the same principle is applied in hydraulic wash also. So the term hydraulic represents the usage of water. Let us see the principle of hydraulic wash. Okay, so this method is mainly applicable to concentrate the ore and the gangue with different specific gravities. That is the main principle behind hydraulic wash. The ore and impurity must have different specific gravity, which means they must be differed by weight. They must have various weights. Okay, then let us see the processing. There are three steps. Step 1 is the ore is crushed to a finely powdered form. We have to crush the ore into a very finely powdered form. That is the first step. So if we look at the diagram, we'll get a clear idea. The crushed ore is taken at the top. Okay, then second step, the powdered ore is treated with a current of rapidly flowing water. Students, again let us look at the diagram. So we have taken the crushed ore at the top of this instrument. Then there is a current of flowing water through this crushed ore. At that time, what will happen is the lighter gangue particles are washed away by water. So look at this picture again. The gangue particles are removed away by water, whereas the ore particles are stored in the sloping table. Okay, so by this we can separate the lighter gangue particles from the heavier ore particles. So only three steps. The ore is crushed into a finely powdered form. Then the powdered ore is treated with a current of rapidly flowing water. At that time the lighter gangue particles are washed away by water. Then we must ask a question, to what kind of ores this method is applicable. So this is mainly applicable to native ores such as gold oxide, tin oxide and hematite. So tin oxide is SnO2 and hematite is Fe2O3. So this is the complete diagram of hydraulic wash. Let us have a complete revision one time. First one, the principle. In this method, the ore and the impurity must be having different specific gravities. Then the process. The ore is crushed into a finely powdered form. Then the powdered ore is treated with a current of rapidly flowing water. And then at that time, the lighter gangue particles are washed away by water. And it is mainly applicable to native ores such as gold oxide, tin oxide and hematite. This is the diagram of the hydraulic wash. Students, I think you all have a complete idea about this hydraulic wash. It is one of the concentration processes of the ore. Thank you.